Good morning. Today I'm going to talk to you about redundant array of inexpensive disks, otherwise known as RAID. So let's begin with a scenario. Say that we are working in a company and we are using a database server which utilizes only a single hard disk. 2 days later, this hard disk fails and we've lost all our data. Now this should never happen in the workplace. So the following considerations which we need to make before we choose RAID is the following things here. So one disk is considered to be too small for a database server. Secondly, one disk is never going to be fast enough to perform all these operations for a database server. Thirdly, should we even be able to find such a disk, it's going to be expensive. The same also occurs with performance. And finally, we need redundancy. So what is RAID? RAID is a data storage virtualization technology that combines multiple physical disk drive components into a single logical unit for the purposes of data redundancy and performance. Now, by single logical unit, it refers to the fact that we've got multiple hard disks, and the way the computer sees it is essentially it sees it as a single hard disk. Data redundancy is a system design in which a component is duplicated, so if it fails, there will be a backup. So, why do we use RAID? Now we use RAID for two reasons. So the first reason is redundancy. So we expect that our hard disk is going to fail sometime in the future, whether it's the first day or several years from now. However, what we do expect is that should we have lost a disk, we should then be able to recreate the data from a backup. This will allow us to save time from tedious and time-consuming work such as disk recovery. Now, the second reason why we choose RAID is because it offers performance. Now, RAID offers performance in a number of ways depending on the type of RAID which we choose. So, first reason why RAID is optimal for performance is it allows us to reduce the amount of strain that's performed on a hard disk. So, by sharing the load, we're allowing it to increase the life cycle of each hard disk. By having more operations on a single hard disk, it puts more load on this hard disk and it also slows down the performance. Now let's look at the levels of RAID. So the first RAID which we're looking at first is RAID 0, which refers to disk stripping. So disk stripping is the process of dividing a body of data into blocks and spreading the data across multiple storage devices such as hard disks or solid state drives. Now in the diagram below we have an example of this where disk 1 has block 1, disk 2 has block 2, and so on and so forth, where the data blocks have been spread across both disks from left to right. The pros with this, so the first thing which we should be grateful for is RAID 0 actually offers great performance, both in read and write options. There is no overhead caused by polarity. And the technology is reasonably easy to implement. The major con and why this is not optimal for a mission critical system like database servers is that RAID 0 has zero fault tolerance, and if one drive fails, all data in the RAID 0 array is lost. So there is no backup with RAID 0 essentially. Now let's look at RAID 1, disk mirroring. Now this is slightly different from RAID 0, where instead of just looking at spreading our blocks across, this time we're looking at configuring the disks so that we have at least two drives that duplicate the storage of data. Now this is optimal for providing us with read speed and write speed that is comparable to a single drive, but more importantly, it gives us redundancy which we need for such database servers. RAID 1 is considered to be very simple to implement as well. The main disadvantage with this, however, is that because we are making such a copy, we're now halving our data capacity. So instead of having 2 disks which would give us 16 gigabytes of memory size, we're now reduced down to 8 because of these copies which we're making. So let's look at RAID 10, stripping plus mirroring. Now the major pro with this is that it offers us the best of both worlds of RAID 0 and RAID 1, where we're getting the read and write performances which we want, but we're also getting the redundancy which we need as well for a database server. And this is why this is considered to be the most optimal solution for a database server. The con with this, however, is that it's far more expensive. A database server utilizing RAID 10 will require at least 4 disk drives. That way we can do the stripping and the redundancy through the mirroring. So finally, let's look at RAID 5, stripping with priority. Now, priority refers to a technique of checking where the data has been lost or written over when it is moved from one place in the storage to another, or when transmitted between different computers. Now, looking at the diagram, we can see that we've got a distributed priority which checks for each blocks across these multiple disks. So disk 0 has block A1, disk 1 has block A2, and disk 2 has block A3, which is then checked by block A priority. And this goes down to all of the block levels. So B1, B2, B3, B4, then etc, etc, etc. So the pros with this is read data transactions are considered to be very fast, but we're making a trade-off here, where our write data transactions are going to be somewhat slower due to the priority, which needs to be then recalculated should we actually move data across. Now, the other pro which we gain is that if a drive does fail, we still have access to all the data, even while the failed drive is being replaced and the storage controller rebuilds the data on a new drive. The con, however, with that, though, is that it'll put more strain on this operation, and therefore be taking more effort to actually obtain other operations. So drive failures do have an effect on the output which you'll be requiring should you be doing multiple things at the same time and still trying to recover your data. This is also considered to be a complex technology. What is required for this type of RAID is that we have at least one disk for priority, and then the other 2 disks will allow for backing up and redundancy problems. So let's conclude it there.